Okay, this is the homework help video for Honors Math 3, Unit 5, Worksheet 1, and we're going to start with question number 7. So the directions say that we have to simplify each radical expression and we have to use absolute value symbols when needed. So that means we're going to have to check for that at the end. So for question number 7, so I need to do a square root of 40. So I'm going to go ahead and do a factor tree over here. So 40 is 4 times 10, and 4 is 2 times 2, and then 10 is 2 times 5. So I'm looking for pairs, so I have a pair of 2, and then I have 2 and a 5 that don't make a pair. So I already have the 3x squared, so I'm going to go ahead and put that just off in front first, and then I'm going to pull out that pair of 2's from the 40, and then I'm going to leave a little space here because I have more to go in. And then 2 times 5 is remaining, so that goes under the radical. Okay, so again, I'm working on number 7. So I know I'm moving on into 8 space, but that's okay. So the 40 broke down to the 2 on the outside and 10 on the inside. And then x is a power, so 1 doesn't divide by 2, so that means it's going to stay here. And then for the 4, so to reduce it, I divide by the index, right? So the index here is an implied 2. So to reduce a power, I divide by the index. But to do a number, like a coefficient, I need to do a factor tree. So then 4 divided by 2 is 2, so that would be y squared. So the 40, factor tree, 2 on the outside, 10 stays in. X doesn't reduce, and then for y to the 4th, 4 divided by 2 is 2, so y squared. And then go ahead and combine like terms, so I have 3 times 2. X squared, y squared, and then the square root of 10x. And then I have no odd power, so I know I don't need to check for absolute value. Okay. And then let's take a look at number, let's do number 13. So I'm doing a cube root of 32, so I'm going to do for the 32, I need to do a factor tree. So 8 times 4. And then I'm going to cross those off because I reduced them already. Okay, so 8 times 4, 8 broke down to 4 times 2, and then 4 is 2 times 2. So this time I'm doing a cube root, right? So because I'm going to do a cube root, I'm looking for triples. So I have that group of 3 there, and then these don't make a group of 3. So for the 32, I have a 2 that I can pull out, and then a 4 needs to stay inside. So 2 on the outside, 4 on the inside. And then x to the 9th. So I'm going to do for powers, I divide, right? For numbers, I do factor tree. So 9 divided by 3 is 3, so that would be x cubed. And then 10 does not divide evenly, right? So I need to ask, how many times does 3 go into 10? So 3 goes into 10 3 times, so that's a y cubed. And then with 1 left over, so 1 left over, so y to the first. So it's like long division, right? So we're like doing long division. So 10 divided by 3. So 3 goes into 10 3 times with a remainder of 1. So y cubed on the outside and then y to the first on the inside. So then that would just give me 2x cubed y cubed and then the cube root of 4y. Okay, and then I don't need to check for absolute value because it's an odd index, so no absolute value needed. Okay, and then let's do one more here on the front side. So let's take a look at number 5. So I'm backtracking here. So I have a negative 3x, so I'm going to just do that right here. And then the square root of 81 is 9. And then I have an index of 2. So 2 goes into 7, so 2 goes into 7 3 times with 1 left over. So 2 goes into 7 3 times with 1 left over. So x cubed, and the remainder on the inside. And then 2 divided by 2 is 1, so that would be y to the first. So then I'm going to combine terms, so I have negative 3 times 9. And then I have 1x here and 3 here, so I have 4 altogether being multiplied. And then y to the first is just y, and x to the first is just x. So now I'm going to check for absolute value because I have an even index. So the power here is odd, so even, odd, no absolute value. Here I have even, even, that turned odd. So an even index, even power, that turned odd. So then I need absolute value here. Okay. All right, and then let's take a look at the back side. Okay, so we're going to take a look at number 19. So I have to do 5 times 50, and then I need to do a factor tree on that. So I'm going to combine it. So I can't use a calculator, so I'm just going to leave it as 5 times 50 because I know I'm going to simplify, so I might as well start from there. So we're going to factor out the 50, so that's 5 times 10, and then 2 times 5. So I have a pair of 5s and then no pairs here. So the pair of 5s and then 2 times 5. Okay, and then for 21, so this is going to be, we can't multiply or simplify over the real numbers, right? Over the reals. So here I have an imaginary number, so this is complex, so then it says to do it over the reals if possible. So this is complex. Okay, so I will have no reals simplifying possible, right? Because that would be 2i. So if we tried to do that, right, that would be 2i and then root 3. And so we don't want to do that one. Okay, and then let's take a look at number 27. So for here I want to just multiply. So I have a negative 1 times 4, so negative 1 times 4, so I'm multiplying what's on the outside first, and then a cube root, and then I'm going to multiply what's inside. So I have 2 times 12, and then I have 3 x's here and 5 x's here, so altogether I have 8. And then I have 2 y's and 1 y, so altogether I have 3. And so now I'm going to do cube root, so I'm going to do my factor tree on the 24 first. And then because it's a cube root, I'm looking for groups of 3, so a 2. So I already have a negative 4 here, and then I'm going to introduce a 2. So negative 4 times 2, so that would give me negative 8. And then I have that 3 left over, so I'm going to leave a little gap here for my variables and put that 3 here. So I'm leaving the 3 here though because of the cube root, and then this 3 is from the leftover 3 from the factor tree. Alright, so now I'm going to do 8, so x to the 8th. So 3 goes into 8 twice, so that would be x squared, with 2 left over, so 2 here. So 3 goes into 8 twice with 2 left over. And then 3 divided by 3 is 1, so y to the first, or just y, and then none left over. And then I don't need to look at absolute values because I have an odd index. So then my answer would be that. And that's it for that video.